Welcome back. So you just made it through the first part of this review. So here we are looking at sum difference, double and half angle problems. So looking at number 6. So really, if we can see a problem as a double angle or as a sum or difference, that is ideal. But for example, sine of 15, I could see that as a difference of 60 and 45. But I'm going to just display how you can use a half angle formula for it. Okay, so 15 degrees. I'm going to figure out, am I using a half or a double? So it's like 2x equals 15. Divide by 2. No, don't like that. Don't like that at all. So that means that most likely I'm going to have a half angle. So x would equal 30. So knowing what I just did, I'm testing whether I'm using a double or a half angle identity. So double angle identity did not work, so I'm using a half angle. So we have, rewriting this, sine of 30 divided by 2, and the identity is positive negative square root of 1/2 times 1 minus cosine of our angle 30 degrees. Okay, so simplifying, we have 1/2. Cosine of 30 is square root of 3 over 2. Okay, and getting a common denominator, we would get 1/2. This is 2 over 2, so we would have 2 minus root 3 over 2, leaving us with positive negative square root of 2 minus root 3 over 4, that's an easy save, over 4, because of 1/2 and divided by 2. Now, we have a positive negative that we have to deal with. So, we are in what quadrant? Well, 15 degrees. We are in quadrant 1. So we're in quadrant 1, and sine in that quadrant is positive. So I could just circle the good old positive. So we have positive 2 minus root 3 over 4, and that is the exact value of sine of 15 degrees. So just looking at the next one, cosine of 255. So 255, let's see, this I could write it as 210 plus 45 degrees. So I'm just, maybe I could have done a half angle or double angle. Maybe I'm showing you what I could have done with a sum on this problem. So let's see. So the cosine identity for sum is cosine, cosine, sine, sine. So cosine of 210, cosine of 45. The signs are different on this identity, and then sine of the first angle, sine of the second angle. Okay, so in that, we have cosine of 210, that is going to be negative root 3 over 2. And then cosine of 45, root 2 over 2. All right, so sine of 210, that is going to be negative 1/2. And then sine of 45 is root 2 over 2. So simplifying, we get negative root 6 over 4. The two negatives turn to addition, root 2 over 4, and we have an exact value of negative root 6 plus square root of 2 over 4, and that's the exact value for cosine of 255. So again, maybe this could have been done with a double or a half angle. I was just showing you what we could have done with a sum identity. All right, so looking at the next one. So tangent of 150 degrees. So I would like for us to utilize both the sum and difference and compare it to the half angle. I already tell you it's going to be a half angle. So the sum and difference. So 150, I could write this as tangent of, well, wait, let's do 180. I like that. 180 minus 30. Okay. So the tangent identity for a difference is tangent of the first angle minus tangent of the second angle, because the signs are the same, and 1 plus tangent of the first times tangent of the second. So maybe, just maybe, I could have done 120 plus 30, but there's a reason why I chose 180, and you'll see in the next line. So tangent of 180 is 0, 0. So then tangent of square root of 30 is square root of 3 over 3. We have 1 plus, that was a nice save, 1 plus, oh wait, this is 0 times something, so just 0. Oh, so we get negative root 3 over 3 over 1, which is just negative root 3 over 3. And that is tangent of 150. And if knowing our unit circle, that's true. We already knew that if we knew our unit circle well. Okay, so we should get the same thing using this half identity. So let's use our half identity. So 150 is half of 300. That's an easy one to find, or easy one to see. So square root positive negative. Okay, 1 minus cosine of 300. 1 plus cosine of 300. An identity, find on our formula sheet. So that is positive negative square root. Cosine of 300 is going to be 1/2. Okay, so I have a common denominator on top and bottom, so I can use my little great trick of multiplying by that value to get rid of the fractions. So when I multiply both top and bottom by 2, I get positive negative 2 minus 1, and then 2 plus 1, because the 2 times 1 and 2 times 1/2 is just 1. All right, so I'm going to write a little arrow sign, so positive negative. This is that's 1 over 3, okay, or just positive negative 1 over root 3, which is positive negative root 3 over 3. And 300 degrees, we are in the 4th quadrant where tangent is negative. Ah, yes, we got the same. Okay, so moving on. Look at the next one. So for question 9, rewrite this as sine, cosine, or tangent. So in looking at this problem, we see, first of all, nothing involving tangent, so it's not going to be tangent. And cosine identity is cosine, cosine, sine, sine, so we have sine, all right, and this is going to be addition, so pi over 12 plus 3 pi over 4. Now it's just a matter of actually simplifying that. So this is sine of 1 pi over 12 over plus 9 pi over 12. Okay, so sine of 10 pi over 12. Could we simplify that to say 5/6? Sure, why not? But they just wanted us to write it as a sine expression. Moving on. So now here we're looking at a situation where we are going to have to use a reference triangle. And how I know that we're going to need a reference triangle is that the fractions that we're given are not fractions that I'm very familiar with. So we have our angle x is in quadrant 2. And with tangent being negative 49, so tangent's opposite adjacent, so we have negative 9 and then 40. Okay, that is again x. And then in quadrant 4, we have angle y, and sine of y is going to be negative 3/5. Okay, so knowing our Pythagorean theorem, this turns out to be exactly 41, and then this missing side turns out to be positive 4. So we need to find all the sides for our triangles before we can continue with our problems. So looking at cosine of x plus y, let's first write this using the identity, the sum identity. So cosine x, cosine y, minus sine x, sine of y. And from here, I find each ratio from my triangles, place it in, and simplify. So we get cosine of x is negative 9/41, if you want to say it that way. Cosine of y is 4/5. All right, so minus sine of x, 40/41, and then sine of y, negative 3/5. All right, so when we multiply the first fraction, we get negative 36 205ths, so 200 over 205, and the minus with the negative addition, 120 205ths. So combining the two, we get a result of 84 over 205, and that is the value of cosine of x plus y. All right, so now looking at the next one, tangent of x minus y. So tangent, again, if you need to, use our formula sheet. So tangent here, we're looking at saying tangent of x minus tangent of y over 1 plus tangent x, tangent y. Okay, so we would write tangent of x, 40 over negative 9, minus tangent of y, negative 3/4. Okay, and then 1 plus, same thing. Okay, so in simplifying this, we find, common denominator. We multiply 40 by 4. We multiply negative 3, actually we remember that as plus, but to positive 3 times 9, that's negative 27. Or we could just leave the negative up here. So we'll do that. We'll leave the negative with the 40. So right, meaning when I multiply 4 by 40, I'm actually going to do negative 40. So negative 160. And then 9 times positive 3 is positive 27. This is over 9 times 4, which is 36. Okay. And then we have 1 plus negative, the two negatives cancel, giving us positive 120 over, again, 36. What is very beautiful about this is that I can multiply both top and bottom by 36 since they are the same. So we're going to multiply by 36, and that gets rid of our fractions. So we get, cancel. We would get negative 160 plus 27 on the top. And we get 36 plus 120. And when we simplify that, we should get negative 133 over 156. And that is the value of tangent of x minus y. So more of algebra than really anything. So now our sine of the half angle, sine of x divided by 2. So we have positive negative square root 1/2 of 1 minus cosine of x. Okay. So half angles are nice and double angles are nice because we only have to use one triangle. So we have here, 1/2 still. 1 minus cosine of x appears to be negative 9/41. Okay, so gives us, we'll do the right as 1 plus now. Okay, so simplifying 2. This is 41 over 41, so 41 over 41 plus 9/41 is 50/41. Okay, which gives us positive negative square root of 50 over 82. All right, now since x is in quadrant 2, so again, angle x is in quadrant 2. So when I divide that angle by 2, I'm going to end up back in quadrant 1. So here we are in quadrant 1 now. So being in quadrant 1, sine is only positive. So we've gone through in this little video, double angle, half angle, and then the sum difference identities. So you're going to see here at the end of the video a little link that can take you to the next and last part of the review that focuses on solving trig equations and application. So again, good luck guys getting ready for your test, and we'll work more and more on this and get a better understanding of it in practice and review.